Good morning, dear students. Once again, I would like to welcome you all for this session of EduSite program on Basics of Electrical and Electronics Engineering. Dear students, in the previous classes, we have studied about the concept of electromagnetic induction. Okay, and the machines which work and which uses this principle of electromagnetic induction. Some of the important machines are DC generator, AC generator, as well as transformers. We also have studied about the working of the generator. And what is generator? Generator is a machine which converts mechanical energy into electrical energy. Okay, so in today's session, let us try to know which is the machine which is used to convert this electrical energy into mechanical energy. Today I am going to explain you about some of the important machines in electrical technology, that is the different types of motors. Okay, so what is a motor? Motor is a machine which converts electrical energy into mechanical energy. In this session, let us discuss about the different aspects of this motor. Okay, so the contents are the working principle of DC motor, the function of DC motors, the different types of DC motors, and the applications of DC motor. First, let us try to know what is a DC motor. DC motor is an electromagnetic machine which converts electrical energy into mechanical energy. It is a dynamic machine. Its action is reverse to that of a DC generator. At the very beginning, I told you that DC generator does the reverse motor for DC generator because the generator converts mechanical energy into electrical energy, whereas this DC motor converts this electrical energy into mechanical energy. But why it is called a dynamic machine? Because it has got some rotating parts. It could also be called as rotor. So it has got two parts, that is a stator which is a stationary, and the other part is the rotor which has the different parts which are under motion. Therefore it could be called as a dynamic machine. Now let us see what is the working principle behind the working of the DC motor. It works on the principle that whenever the current carrying a conductor is placed in a magnetic field, it experiences a force and tends to move at right angles to the direction of magnetic field.
Direction of the magnetic field. This could be explained with this scale. We just observe the diagram, this diagram, that is, this is the magnetic field. These are the two poles of the magnet, that is south pole and the north pole. A conductor has been placed inside the magnetic field, and when this conductor carries this, the ends of the conductor, they are connected to the commutator. To the two sides of the commutator there will be two brushes, and the two brushes are connected to the terminals of the power supply, that is the battery. So this battery acts as the EMF source, and when current starts flowing through the conductor which is placed in between the magnetic field, then what happens? Because of that conductor, it is carrying current, and the current carrying conductor is placed in the magnetic field. Because of that one, it experiences a force, and because of that force, this conductor tends to move in right angles to the direction of the magnetic field. That is seen in the second figure. So this is the figure which shows the conductor which is placed in the magnetic field. Here, as the current passes through the conductor, because of the force which is experienced by the conductor, it tends to move at right angles to the direction of the main field. So because of this property only, the motor is able to rotate in the magnetic field, because it is experiencing a force. So the force which is experienced by the conductor could be explained by the rule called the Fleming's right hand rule. That is, what would be the direction of the current, what would be the magnetic field, and the direction of the force. It could be known with the help of the law called the Fleming's left hand rule. So what does this Fleming's left hand rule says? Fleming's left hand rule says that if you stretch the first three fingers of our left hand, this is the left hand, and the first three fingers, that is the thumb, the forefinger, as well as the middle finger. If these three fingers of the left hand, therefore it is called as left hand rule. Okay, if the first three fingers of our left hand are stretched at right angles to each other, you just observe the figure, all the three fingers are at right angle to each other, then the forefinger indicates the direction of the magnetic field. This is the direction in which the magnetic field is acting, that is in the direction of the forefinger. Okay, so the forefinger shows the direction of the magnetic field. And what does this middle finger indicates? The middle finger indicates the direction of current. So the direction of current is given by the direction in which the middle finger is indicating, and the direction of the thumb, it shows the direction of the current. So if the magnetic field is acting in this direction, and if the current is flowing in this direction, that is the conductor carries the current in this direction, then the direction of the force which is experienced by the conductor will be in the upward direction. Therefore, the direction of the force, the direction of the magnetic field, as well as the direction of the current, everything can be observed with the help of the law called the Fleming's left hand rule. So, how does this DC motor works? The DC motor works like this. There will be two magnetic field, one due to main field. That is, actually the conductor is placed in the magnetic field. Okay, so because of the magnetic field, that field is known as main field, and the other will be due to the current in the armature conductors. Students, all of you know that whenever the conductor carries the current, there will be the existence of the magnetic field around that conductor. So there are two fields now. One is the field established by the poles of the magnet. Another one is the field established by the current carrying armature conductors. So here there are two fields. So the resultant field, due to the spring action of the resultant field of the conductor, so the conductor is experiencing a force because of this resultant field, and because of the resultant field, the conductor starts rotating, and hence the armature on which the conductor is placed, it also rotates in the specific direction depending on in which direction the current is flowing in the conductors of the armature. This diagram shows the working of the DC generator. This is the magnet, that is north and south pole. It shows the two poles of the magnet, and this is the horseshoe magnet, and this yellow color line, this band shows the conductor, and there will be a source of EMF, that is the battery, and the two brushes are connected to the two ends, where the ends of the conductor is connected to the commutator segments. Whenever there is current flow through the brush and then to the commutator and then to the conductor, then what happens? Already there is a field existence due to the presence of the magnet, and when this conductor carries the current, then because of that one there will be another magnetic field. So there are two fields. One is the field established by the main pole, the main magnet, and another one is the field established by the conductor. So as a result, the resultant force will be there, that resultant field will be there. Therefore, because of this one, the conductor is experiencing a force. Therefore, the conductor starts rotating. Since the conductor is placed on the armature rotates, and hence there will be a motion of the armature in the particular direction depending on the direction in which the current is flowing in the armature conductors. And this diagram shows the different parts of the motor. Okay, now I think you have become familiar with the different parts of the DC generator. So constructionally, both motor as well as generator, both are one and the same. That is, both generator as well as DC motor, they have same type of different parts. Okay, so mainly we can classify the parts of the generator motor into two main classification. That is, one is the stator and another one is the rotor. The stator parts consist of the yoke, that is the outer cover, and as well as the magnetic field. The magnetic fields, there will be two different magnetic fields, that is the south pole as well as the north pole, and the conductors which are placed over the poles, and they are known as the field coils, and below that field structure there will be the structure called the armature, and this section of the motor, it is known as the rotor structure since it keeps on rotating. Okay, the armature has got conductors, so these conductors which are placed in the armature, they are known as armature conductors. So similar to generator. In case of motor also there will be two different types of conductors. One is the field conductors or the field coils, and another one is the armature conductors which are there in the armature structure. Okay, and to the armature, the front part of the armature there will be a commutator, and the commutator is split in two parts, and the brushes will be connected to the ends of the commutator on the either side of the commutator. You can see these brushes A and B. These are the two brushes, and they will be placed at the two sides of the commutator. Okay, so these form the different parts of the motor. So the different parts of the motor are the yoke, the outer section, the magnetic poles, and there will be conductors to carry current, and these conductors are known as magnetic coils or the field coils. And below this field structure there will be another structure called the armature, and the armature houses the conductors. These conductors actually carries the current. Because of the current flow and the magnetic field developed by these conductors which are there placed on the armature, and the magnetic field which is developed by the main field, that is the north and south pole, there will be a resultant field, and because of that resultant field the motor starts rotating in the specific direction. Now let us try to know what are the different types of DC motors. The different types of DC motors are classified basically on the way in which the field windings are connected with the armature windings. Okay, so based on this configuration there are three different types of motors, namely the series motor, shunt motor, as well as the compound motor. Okay, again the compound motors are classified into cumulative compound and differential compound motors. The cumulative compound motors are subclassified into short shunt cumulative compound motors and long shunt cumulative compound motors. In the same way, the differential compound motors are also classified into short shunt compound motor and long shunt compound motor. Okay, this diagram shows a shunt motor. So what do you mean by a shunt motor? This is the armature, and this shows the conductors in the field winding. So this is the field winding and this is the armature structure. If the field winding is connected in parallel with the armature conductors, then that type of motor is known as shunt motor. Okay, so whatever input voltage is there, and across that input supply the shunt field winding as well as the armature field winding both are connected in parallel. So this configuration, that is if the shunt field winding is entirely in parallel with the armature windings, then that configuration is known as shunt motor connection. Next one is the series motor. You just observe the figure. In this case, this is the armature structure and this is the series field coil. Okay, unlike to this shunt motor, in this case the armature is not connected in parallel with the series field coil. Instead, you can observe in the figure, the series field coil is actually connected in series with the armature. Since the series field coils are connected in series with the armature, this type of motor is known as series motor. Okay, in this case, whatever current which flows to the field coil is same as that of the current which is carried by the armature. Because both are connected in series, you know that in series circuit the same current flows through all the elements which are in series. Therefore, the current carried by the series field coil in series motor is high when compared with the shunt field type of or shunt motor, wherein the shunt field coil is connected in parallel with the armature. Whereas in case of the series motor, series field coil as well as the armature are connected in parallel. This diagram shows the cumulative compound motor. Why it is called as cumulative compound? Actually, it is a compound motor. What do you mean by a compound motor? A compound motor is one which consists of both the series field coils as well as the shunt field coils. Here, there will be two different types of field coils. One is the series field coil and another one is the shunt field coil. In case of shunt motor, there was only shunt field winding. In case of series motor, there was only series field winding. Whereas in case of compound motors, there will be two different types of field windings. One is the series field winding and another one is the shunt field winding. Since the combination of both the types of field windings, they are connected, and they are connected with the armature. Series field winding is connected in series with the armature, whereas shunt field winding is connected in parallel with both series field as well as armature winding. This type of connection is known as compound motors. Again, in compound motors we have two types, cumulative compound and differential compound. This diagram shows a cumulative compound motors. Okay, but again in cumulative compound motors there is a subclassification based on how the shunt field winding is connected with the armature as well as the series field winding. Okay, just look at this diagram. How the shunt field winding is connected with the armature as well as the series field winding. The series field winding is actually connected in series with the armature, and the shunt field winding is connected across this series combination of the series field as well as the armature. So this type of configuration is known as long shunt configuration. What do you mean by long shunt configuration? Long shunt configuration is one wherein the shunt field winding is connected in parallel with the series field winding as well as the armature field winding. You just look at this diagram. This is called short shunt cumulative compound motor. So what is short shunt cumulative compound motor? In this case, the shunt field winding is not in parallel with both series field winding as well as armature. Instead, the shunt field winding is connected in parallel with only the armature conductors. Okay, therefore this type of configuration is known as short shunt motor. Okay, so the parallel connection of armature conductors as well as the shunt field winding will be there, and the series field winding is connected in series with this parallel configuration of the motor. Therefore it is known as short shunt motors. Next type is differential compound motors. I have told that the compound motors are of two types. One is cumulative compound and another one is the differential compound. It's similar to cumulative compound. In this case also there are two types of differential compound motors. One is long shunt and another one is short shunt. What is this differential compound motors? Okay, in case of cumulative compound motors, the series field winding and the shunt field winding are connected in such a way that the field developed by the two, they will aid each other. Okay, in case of differential compound motors, in this case also there will be two field windings. One is the shunt field winding as well as the series field winding, but in this case the fields developed by the two, they will not aid each other, instead they will oppose each other. Therefore this is known as a differential compound motors. So in this way there are different types of DC motors, namely series field winding, shunt field winding and compound motors. Again in compound motors we have cumulative compound as well as the differential compound motors. Now let us see what are the applications of these motors, that is the applications of DC motor. First let us look at the DC series motor. So what is a DC series motor? A motor in which the series field windings will be in series with the armature conductors. Therefore it is known as DC series motor. Since the series field winding is in series with the armature, therefore it is known as series field winding. The same current will be carried by the field windings as well as the armature. Therefore in this case the current flowing in the field winding is very high. Therefore these motors are used under the following conditions. What are those conditions? Where the load is directly connected to the motor, where the high starting torque is required. Okay, high starting torque means higher value or higher magnitude of the current. In this case the magnitude of the current is high, therefore the starting torque will also be high. Therefore these motors are applicable where high starting torque is required and when the load is connected directly to the motor. So these motors are used for running trains, trams, cranes, fans, trolleys, conveyors as well as hoist. These are the different applications. All these applications they demand high starting torque, whether it is train, trams, cranes, fans or trolleys. Therefore DC motors are employed in all these cases for running of trains, fans, trolleys, etc. Okay, next let us look into the applications of shunt motors. This is a general purpose motor which is conveniently used under the following conditions. Okay, what are those conditions? In this case, the field winding is actually connected in parallel with the armature conductors. Therefore, by using this motor, it is possible to obtain a constant speed. Therefore, this type of motor is also known as a constant speed motor. So, it could be employed where a constant speed is required, and also where a medium torque is required. Therefore, this type of motor is used for lathe machines, woodworking machines, machine tools, centrifugal pumps, fans, blowers as well as conveyors. All these applications, they demand a constant speed and a medium torque. Therefore, all these motors, they employ shunt motors. Okay. Next, let us look into the applications of the cumulative compound motors. Okay, these motors are used in the following conditions. That is, the first condition is where there is a sudden change in the load, and another one is where large starting torque and a fairly constant speed is required. Okay, you know that large starting torque could be obtained with series configuration and constant speed could be obtained with the shunt configuration. Since the compound motor is a combination of both series field winding as well as shunt field winding, therefore it is known as a compound motor. The combinational characters can be observed in cumulative compound motors. Therefore, these motors could be employed where there is sudden fluctuations in the load, if it is heavily fluctuating, and high starting torque is required and a constant speed operation is required. So, these motors, they are used in cranes, elevator, lifts, rolling mills, conveyors, crushers, punching presses, hoists, shearing machines as well as punching machines. So, these are the different applications of the motor, that is cumulative compound motor. And when you come to the case of the differential compound motor, these motors very rarely used where high starting torque is required with the constant speed. In this case, the speed increases as the load decreases and also the torque increases as the load increases, because the two field windings, that is the shunt field winding as well as the series field winding, the field developed by these two, they will oppose each other. Therefore, this type of motor is very rarely used. So, these are the different applications of the motors, that is the DC motor. Dear students, so far we have studied about the different aspects of the DC motor. That is, in this class I try to explain about the different constructional features of the DC motor, the working principle of the DC motor, the different types of DC motor as well as the different applications of the DC motor. Now let us try to know the other type of the motor known as AC motor, and also the coming slides will show you the different applications of the DC motors. Okay, this slide will show you the different applications of the DC motor, that is, it is used in tramways and then buses, and it is also used in vehicles. And this diagram shows the DC motors in the lift applications. This diagram shows the DC motors in the chemical injection pump applications. This slide will show you the application of the DC motor used in electric hoists, reels and the winches. And this diagram, this picture will show you the application of the DC motor in lifts and hoists as well as cranes. And this slide will show you the application of the DC motors in remote control and power switching applications. And this is the application of the DC motor in electric vehicles. And this slide will show you the application of the DC motor in mobile high voltage AC applications. And this slide will show you the application of the DC motor as a pump motor, that is hydraulic pump applications. So with this, we have come across the different applications of the DC motors. Now let us try to know about another important type of the motor, that is called the AC motor. Okay, so the different aspects we are going to study under this heading of AC motor is AC motors, the function of AC motors, the types of AC motors, the applications of AC motors, the mechanical enclosures which are used with these motors, and what are the different types of enclosures and the applications of these enclosures, and fractional HP motors and the types of fractional HP motors and their applications, and the necessity of starters as well as different types of starters. First, let us try to know what is an AC motor. An AC motor is an electric motor driven by an alternating current. Basically, the motors could also be classified as DC motors as well as AC motors. If the motor is driven by direct current, then it is known as a direct current motor or DC motor. If the electric motor is driven by an alternating current, then it is nothing but alternating current motor or AC motor. Okay, there will be two different basic parts of the AC motor. The two different parts are once again the stator as well as the rotor. So what is a stator? This is the outside stationary part of the motor having coils supplied with alternating current to produce a rotating magnetic field, and the other basic part of the motor is the inside rotor. It is attached to the output shaft that is given a torque by the rotating field. So there will be a stationary part that is called the stator, there will be a rotating part that is called the rotor. These two, they form a electric motor, that is AC motor. Okay, this diagram shows how the rotating field has been developed by the motor. That is the two poles, there will be two poles, and this is the rotor. This is where this is the magnetic field, whereas the magnetic field is stationary, but because of the supply there will be rotating magnetic field has been developed. To that one there will be a rotor connected which is inside the stator. Because of the rotating magnetic field, the conductors which are placed over the armature, it starts rotating. Okay, so what is the function of the AC motor? So the AC motors could be of the two types, that is a single phase AC motor as well as three phase AC motor depending on the available supply. Now let us look into the simple type of motor called the single phase AC motor. What is single phase AC motor? A single phase AC motors are a type of induction motors which, as the name implies, they operate on one phase or the single phase. Since the available supply is of single phase type, this type of motor is known as single phase AC motor. In single phase induction motors, a single phase supply voltage is split into two phase currents because for the working of the AC motor it needs a rotating magnetic field. But with the available single phase supply, this rotating magnetic field will not be generated. Therefore, in order to create this rotating magnetic field, the available supply voltage is split into two phase currents. So when it is split into two different currents, then it becomes a two phase supply. Since the available supply is of two phase, these two phases are sufficient to create a rotating magnetic field in order to start the rotation of the rotor, because there should be two fields. So because of that one, the available supply is split into two different currents, that is two phase currents. Because of this two phase currents, there will be a rotating magnetic field. Because of this rotating magnetic field, there will be the rotation of the rotor. The types of the motor define the method used to achieve the phase splitting. Okay, the rotating magnetic field can be observed in this figure. You just observe the field coils. In this case, there will be two fields. This is one field and another field, and this is the magnet which is placed. So by experiencing the force, the magnet is rotating in this case. This represents the rotating magnetic field, and this one shows the arrangement of the stator as well as the rotor. There will be two windings. One is the main winding and another one is the starting winding. This is the winding which is used at the starting of the motor. Therefore, this type of winding is known as starting winding. Now, let us look into the different classifications of the AC motors or types of the AC motors. There are two different types of AC motors depending on the type of the rotor used. There will be different types of rotors used. Therefore, based on what type of rotor is used, there will be two main types of AC motors. That is the asynchronous motor and another one is the synchronous motor. Asynchronous motors are also known as induction motors. So induction motor or asynchronous motor, they are one and the same. This type relies on the small difference in speed between the rotating magnetic field and the rotor to induce rotor current. Whereas in the synchronous motor, the magnetic field on the rotor is either generated by the current delivered through slip rings or by the permanent magnet. So these are the two main types of the AC motors, that is the induction motor as well as the synchronous motor. There is third type, and the different types of motors, they will be considered as other types of motors. They include eddy current motors, AC or DC mechanically commutated machines. These are the different type of motors. So we can say that there are three different type of motors, namely induction motor, synchronous motor and the other type of motors. The different type of motors are shown in this diagram. These diagrams of the pictures, they shows the different type of motors. And also based on the supply which is given to the motor, AC motors could be single phase, two phase or three phase motors. Okay, if the single phase supply is given, then that is called single phase supply. Two phase supply is given, it is called two phase. If the available supply is three phase, then that type of motor would be called as a three phase motor. The types of single phase AC motor. Okay, the different types of single phase AC motors are the split phase motor, capacitor start motor, shaded pole motor and repulsion motor. These are the different type of rotors which are used to start the machine. Okay. What are the applications of the single phase motors? The different applications of the single phase motors are, they are used in power tools, washing machines, fans, cloth dryers, food processors, vacuum cleaners, surface logs, oil shut-off valves and electric clocks. These are the different applications of single phase motors. You can see that there are various and numerous applications of single phase motors. The coming slides will show you the application of the three phase motors. Okay, as I told, the motors, AC motors are broadly classified into two types, that is single phase and three phase or polyphase machines depending on the available type of the supply. This is another type of motor that is called the three phase motor because the available supply is three phase. Let us look into the applications of the three phase motors. What are the different applications? Induction motors are the motors which are with variable speed. Therefore, they are known as variable speed drives and variable frequency drives. Therefore, the different applications of the three-phase motors are centrifugal pumps, compressor presses, bending machines, machine tools, cranes and hoists, elevators or lifts, vehicles, lathes, drilling machines, printing machines as well as blowers. These are the various applications of the three-phase motors. Now let us look into the applications of the another important type of three-phase motors, that is the synchronous motors. This slide shows the picture of the synchronous motor. What are the applications of the synchronous motors? The different applications of synchronous motors are, they are used in analog clocks, timers, tape recorders, precision servo motors. These are the applications of the synchronous motors, wherein the speed of these motors is constant. These slides will show you the applications of the induction motors. They are used in the oil wells. Once again, they are used in the cranes and hoists. They are used in chemical industries. Also, they are used in aircrafts, robotic arms, and then machine tools, lathes. And this slide, they will show you the differences between the single phase as well as the three phase motors. What are the differences between single phase and three phase motors? The major difference between the single phase and three phase motors is single phase induction motors cannot produce starting torque because the single phase supply cannot produce rotating magnetic field. Okay, at the beginning, while giving the introduction to induction motors, I told you that the available single phase will be split into two phases so as to create the rotating magnetic field. If there is no rotating magnetic field, there will not be starting torque. Therefore, this single phase induction motor, they cannot produce starting torque because the available supply is single phase, and single phase supply cannot produce rotating magnetic field. Whereas in case of the three-phase induction motor, the available supply itself is three-phase, therefore the starting torque will be generated because of the three-phase supply. Therefore, the three-phase supply can produce rotating magnetic field. Okay. Therefore, the single-phase induction motors are not self-starting, whereas three-phase motors are self-starting. Because the supply is three-phase, therefore it could create a rotating magnetic field. Since a rotating magnetic field is created, there will be starting torque. Whereas the single phase motor, they are not capable of creating a rotating magnetic field, therefore they are not self-starting. And the third difference between the two, that is these motors, that is single phase motors, they have pulsating torque, whereas the three phase motors have smooth torque. There will not be any pulsating torque. Whereas in case of single phase motors, the power factor and efficiency are less because the losses are more, therefore the efficiency is less in case of single phase induction motors. Whereas in case of three phase motors, the power factor and efficiency are high. Okay. And another important difference between the single phase and three phase motors are, single phase motors are built only for smaller capacity, whereas three phase motors are built for larger capacity. So these are the differences between the single phase as well as three phase motors. What are the differences? Single phase motors are not self-starting, single phase motors have pulsating torque, and single phase motors cannot produce rotating magnetic field. Single phase motors have low power factor, low efficiency, and therefore they are built for smaller capacity. Whereas three phase motors, they have self-starting and they can produce rotating magnetic field, therefore they are self-starting, they have smooth torque, the power factor as well as the efficiency are high, and they are built for larger capacity. So now let us look into another aspect called the mechanical enclosures. Okay, so what are the mechanical enclosures? The mechanical enclosure, it is a cabinet for the electrical or electronic equipment to mount the switches, knobs as well as displays. The enclosure is the only part of the equipment which is seen by the user. Actually, it is the outer part which is visible. The enclosures are the outer covers provided to electrical machines and equipment. So what is an enclosure? Actually, it is a protective cover which is placed over the machines. This is the protective cover which could protect all the